June 7th, 1944. Omaha Beach, Normandy. Major Heinrich Weber stood in the concrete bunker overlooking the blood-stained sand, watching something that made no tactical sense whatsoever. American trucks were driving out of the English Channel, not landing from boats, not being carried by larger vessels, actually driving through the surf, climbing the beach gradient like mechanical amphibians, and continuing inland as if the boundary between water and land was merely a suggestion rather than a physical law. The vehicles looked clumsy, almost comically ungainly. 31 feet of boat-shaped steel body, mounted on what appeared to be a standard truck chassis, with 6 wheels that seemed absurdly inadequate for serious amphibious operations. Weber had spent 19 months fortifying this coastline under Field Marshal Rommel's direct supervision, studying every Allied landing craft design through captured intelligence reports and reconnaissance photographs. He knew the British LCTs with their clamshell doors. He understood the American Higgins boats and their tactical limitations. He had documented the various tracked amphibious vehicles that intelligence had photographed during training exercises in England. But these hybrid machines represented something German military doctrine hadn't prepared him for. Something that challenged fundamental assumptions about amphibious warfare that had been developed over decades of professional military analysis. They were swimming across open water at 6 miles per hour, then accelerating to 45 miles per hour on sand, delivering 5,000 pounds of ammunition directly to American artillery positions without requiring dock facilities, specialized unloading equipment, or even a pause to transfer cargo between vessels. The operational efficiency was devastating in its simplicity. By the time Weber's superiors received his field report 3 days later, these strange American trucks had moved 18,000 tons of supplies across Normandy beaches that German planners had assumed would be logistically unusable without capturing major port facilities. The vehicles the German High Command had dismissed as mechanically impossible were sustaining an invasion that would change the course of the war, transforming beachheads into supply depots faster than Wehrmacht counterattacks could organize effective responses. Weber realized with growing unease that he wasn't watching inferior American engineering. He was watching the collapse of every assumption German planners had made about amphibious logistics, supply chain vulnerability, and the fundamental requirements for sustaining modern mechanized warfare across contested shorelines. The morning before D-Day had found Weber confident in his defensive preparations, almost comfortable in the certainty of German tactical superiority. 18 months of intensive construction had transformed 50 miles of French coastline into what Field Marshal Rommel had publicly called the Atlantic Wall's most formidable sector. Concrete bunkers positioned with mathematical precision to create interlocking fields of fire that would shred any landing force attempting to cross the beach. Artillery batteries calibrated to strike landing craft at ranges calculated down to the meter. Beach obstacles designed by experienced military engineers to tear open the hulls of any vessel attempting to ground itself on Normandy sand during the predicted high tide windows. German intelligence had been thorough, almost obsessive in analyzing Allied amphibious capabilities. Weber's briefing documents, updated monthly with information from reconnaissance aircraft and captured Allied planning materials, contained detailed assessments of British landing craft specifications, American Higgins boat capacities, and various experimental designs that had been captured or photographed during earlier Mediterranean operations. The consensus among German naval architects, based on careful technical analysis and historical precedent, was crystal clear. Amphibious operations of the scale required to liberate France would require specialized port facilities, or at minimum protected harbors, where supplies could be efficiently transferred from ocean-going vessels to smaller craft, capable of reaching beaches. The Allies would need to capture Cherbourg or another deep-water port within 72 hours, German planners insisted with professional certainty, or their invasion would collapse under its own massive logistical weight. Modern mechanized armies consumed staggering quantities of supplies that exceeded anything seen in previous conflicts. Each division required 600 to 700 tons of food, fuel, ammunition, and equipment daily, just to maintain minimal operational effectiveness. Without port facilities capable of handling Liberty ships and other large cargo vessels efficiently, the Allies couldn't possibly sustain 36 divisions on French soil for the extended campaign necessary to break through German defensive lines. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Weber's confidence wasn't arrogance or propaganda-induced delusion. It reflected careful German analysis of amphibious warfare's fundamental challenges based on extensive historical study and professional military education. The Wehrmacht had systematically studied every major landing operation since the Great War, documenting failures and successes with Prussian thoroughness. Gallipoli, in 1915, had demonstrated with brutal clarity what happened when invading forces couldn't establish adequate supply lines, despite achieving initial tactical success. The British evacuation from Dunkirk in 1940 had shown how vulnerable beach operations were to determined defence when air superiority shifted. Even American landings in North Africa and Sicily had struggled significantly with logistics, despite facing relatively light opposition compared to what awaited them in France. The problem was mathematical and unavoidable, Weber believed. Large cargo ships required deep water and sophisticated dock facilities, including cranes, storage areas, and rail connections. Small landing craft could reach beaches but carried severely limited cargo and required multiple exhausting trips between offshore vessels and shore, creating bottlenecks that artillery and air power could exploit. The gap between ship and shore represented a fundamental bottleneck that no amount of Allied planning or industrial capacity could eliminate. Also, German military theory insisted with confident certainty based on centuries of naval warfare experience. But on the morning of June 6th, Weber watched his carefully constructed defensive assumptions collapse, along with the Atlantic Wall itself, under an onslaught that exceeded his worst projections. The Allied bombardment had been devastating in its precision and overwhelming scale. Naval guns firing from battleships and cruisers positioned offshore had pounded German positions with accuracy that exceeded anything Weber had experienced during 3 years of Eastern Front campaigns where Soviet artillery had been. Formidable but rarely this precise. Allied aircraft had achieved complete air superiority before the first soldier landed, interdicting German reinforcements attempting to reach the coast and destroying communication networks that Field Marshal Rommel had spent months establishing. Then came the landing craft in numbers that defied comprehension. Thousands of them covering the ocean surface like mechanical locusts. More vessels than Weber had imagined existed in all the world's navies combined, organized into waves that maintained relentless pressure despite devastating German defensive fire. Higgins boats disgorging infantry directly onto the sand under machine gun fire. LCTs grounding themselves to deliver tanks and artillery pieces that immediately engaged German positions. Tracked amphibious vehicles crawling across the beach like mechanical insects, their treads churning through sand that conventional vehicles couldn't navigate. The sheer volume overwhelmed German defensive fire through simple mathematics that training and courage couldn't counter. For every landing craft destroyed by German guns, 3 more reached the beach successfully. For every vehicle knocked out by artillery, 5 more survived to deliver their cargo and return for additional loads. By nightfall on D-Day, over 130,000 Allied troops had come ashore along with 17,000 vehicles, numbers that exceeded German intelligence estimates by margins that suggested either catastrophic intelligence failures or Allied deception operations of unprecedented sophistication. But Weber noticed something during the second day that disturbed him more profoundly than the invasion's overwhelming initial scale. Among the conventional landing craft and tracked amphibious vehicles that military doctrine had prepared him to recognize, he kept seeing those peculiar truck-boat hybrids that defied easy classification. They appeared ungainly, almost comical in their design awkwardness. 6 wheels that looked too small for the vehicle's bulk. A boat hull that seemed too shallow for serious ocean travel. Thin steel plating that wouldn't stop rifle fire, let alone artillery fragments or mortar shrapnel. Yet these strange machines were performing missions that German engineers had considered theoretically impossible and operationally impractical. They drove directly from cargo ships anchored 2 miles offshore to shore without requiring specialized landing craft as intermediaries, eliminating an entire transfer point in the logistics chain. They navigated through surf conditions that would swamp conventional boats and ground. Conventional landing craft. They climbed beach gradients that stopped tracked vehicles, designed specifically for amphibious assault. Then they accelerated inland at speeds no amphibious platform should theoretically achieve, delivering their cargo directly to forward artillery positions and supply depots before returning to the water for another load without pausing for maintenance or crew rest. Weber sent a runner to division headquarters with an urgent request for intelligence assessment, expecting German thoroughness to provide immediate answers. What were these vehicles exactly? Where had they come from? How many did the Allies possess? What were their tactical capabilities and operational limitations? The response arrived on June 9th with characteristic German bureaucratic precision but devastating strategic blindness. The vehicles were designated DUTW, according to intercepted American communications, an apparent manufacturer's code rather than a tactical designation. Approximately 2,000 units were believed to be in the Normandy theatre based on ship-loading manifests that intelligence had partially reconstructed. They were considered experimental equipment being field-tested under combat conditions and not expected to significantly impact large-scale operations given their modest individual specifications. The assessment was catastrophically, almost tragically wrong in ways that would become evident within days. By June 11th, Weber's observation posts were documenting something that made him question whether his urgent reports were being taken seriously by higher command or simply filed away as tactical minutiae. The DUKWs weren't experimental curiosities being cautiously tested in limited scenarios. They were the operational backbone of Allied logistics, the essential link sustaining an invasion that was expanding faster than German doctrine suggested was possible, without capturing major port facilities. Conservative estimates based on Weber's careful observation and documentation suggested these strange vehicles were moving approximately 40% of all supplies coming ashore during the critical first 2 weeks. 40%. Not through captured ports like Cherbourg, which hadn't fallen yet, not through specialized harbor facilities, which the Allies hadn't had time to construct, but directly across open beaches in surf conditions that German planning had assumed would make sustained supply operations logistically impossible for any invading force. Weber had spent 4 years in the Wehrmacht studying military logistics with characteristic German thoroughness, understanding the brutal mathematics of supply that constrained every military operation. A mechanized division consumed its own weight in supplies every few days during active operations. Artillery batteries fired shells faster than supply chains could deliver replacement ammunition unless railroads remained operational. Armor units required fuel-intensive quantities that strained transportation networks specifically designed for that exact purpose. Every military operation Weber had participated in or studied during his officer training had been fundamentally constrained by the same immutable problem: getting supplies from factories to front lines across distance and through contested territory. The German logistics system reflected this harsh reality with characteristic efficiency and sophistication. Elaborate transportation networks moved material by rail to regional supply depots, then by truck convoy to forward positions under military police escort. The system worked brilliantly when rail lines remained intact and roads stayed open to military traffic. It collapsed catastrophically when Allied aircraft destroyed bridges or partisan attacks cut supply routes at critical junctions. The Wehrmacht's ultimate defeat in the Soviet Union owed as much to logistics failures as to battlefield reversals, a lesson that German professional officers understood with painful clarity. Now Weber watched the Americans solve fundamental logistics challenges using vehicles that simply shouldn't work according to German engineering principles. The DUKWs required no ports, no rail lines, no specialized infrastructure beyond what they carried within their own mechanical systems. They simply drove through water using a propeller, climbed onto land using their wheels, delivered their cargo using built-in winches and ramps, and returned for more loads without requiring extensive maintenance between missions. The operational tempo was devastating to German defensive planning. German calculations had assumed the Allies would need 5 to 7 days minimum to establish functional supply lines supporting sustained offensive operations. The DUKWs were delivering ammunition and fuel within hours of the initial landing, enabling Allied forces to maintain offensive pressure that prevented German forces from organizing effective counterattacks. The intelligence report Weber received on June 10th provided technical specifications that initially seemed reassuring to German analysts trained to evaluate equipment through the lens of engineering excellence. The DUKW weighed 7.5 tons fully loaded, modest by German military vehicle standards. Its GMC six-cylinder engine produced 270 cubic inches of displacement with unremarkable horsepower output. Its steel plating ranged from 1/16 to 1/8 inch thick, barely sufficient to keep water out of the cargo compartment, let alone provide protection against small arms fire or artillery fragments. Its top water speed was 6.4 miles per hour, slow enough that determined swimmers might theoretically keep pace over short distances. These specifications described a vehicle with obvious, almost embarrassing vulnerabilities that German engineering culture would never accept in military equipment. Light armor meant machine gun. Fire could easily disable the vehicle and kill its crew. Slow water speed made it an almost stationary target for coastal artillery during the extended period when it remained in range of shore-based guns. Limited cargo capacity of 5,000 pounds seemed grossly inadequate for serious logistics operations, sustaining multiple divisions engaged in sustained offensive combat. The thin hull construction suggested fragility that would make the vehicles unsuitable for extended combat operations in harsh conditions. Yet somehow these apparently crippling limitations didn't matter in actual operational employment. The DUKWs kept coming in endless waves, kept delivering supplies without pause, kept sustaining an invasion that was overwhelming German defences through sheer material abundance rather than technical superiority. The contradiction between theoretical vulnerability and practical effectiveness gnawed at Weber's engineering sensibilities. Weber began compiling meticulously detailed observations for his superiors, documenting patterns that challenged German assumptions about military vehicle design. The DUKWs operated effectively in all weather conditions that allowed any beach operations whatsoever. They navigated successfully through surf that grounded conventional landing craft against sandbars. They crossed obstacles and traversed terrain that stopped tracked vehicles designed specifically for amphibious assault. Most significantly, from a strategic perspective, they eliminated the ship-to-shore transfer bottleneck that German planning had assumed was physically insurmountable, given the limitations of existing technology. Traditional amphibious operations, as practiced by all modern militaries, required cargo ships to anchor offshore, beyond artillery range, transfer supplies to specialized landing craft at sea, which then delivered material to the beach where it had to be unloaded again and moved inland by separate trucks. Each transfer point created inevitable delays and vulnerability to enemy fire or weather disruption. The system worked but imposed severe constraints on the rate at which supplies could flow from ship to front line. The DUKWs eliminated 2 entire transfer points through their hybrid design. They loaded cargo directly from ship holds while floating in open water, then drove that same cargo inland to supply depots without ever transferring it to other vehicles. The efficiency gain wasn't incremental or marginal. It was exponential, revolutionary, transforming the fundamental mathematics of amphibious logistics in ways that German planners were only beginning to comprehend. By mid-June, Weber's detailed reports were documenting DUKW capabilities that seemed to violate basic engineering principles as taught in German military academies. The vehicles could adjust their tire pressure from inside the cab using a system designed by an MIT engineer named Frank Speer, allowing optimal traction on surfaces ranging from soft beach sand to hard paved roads without requiring crews to dismount and manually adjust each tire. They could operate in water depths up to 3 feet while still using their wheels for propulsion, combining water propeller drive with ground traction for maximum efficiency in the critical surf zone where most amphibious vehicles struggled most severely. They carried high-capacity bilge pumps that could keep them afloat and operational even when their thin hulls were punctured by small arms fire or shrapnel, a vulnerability that German engineering culture would have solved with heavier armor, but which American pragmatism addressed through pumping capacity. The more Weber studied these vehicles through direct observation and examination of disabled examples, the more he understood that German military thinking had fundamentally missed something about modern industrial warfare. German engineers had historically focused on maximizing individual vehicle capabilities through sophisticated design and precision manufacturing, armor protection designed to defeat the latest anti-tank weapons, heavy weapons systems that required specialized training to operate, sophisticated equipment for specific missions that achieved superior performance in ideal conditions. This approach produced remarkable vehicles that reflected centuries of German military tradition and engineering excellence. The Americans had focused on maximizing system efficiency across entire logistics networks, simple vehicles that could be produced quickly in massive numbers, equipment that could be operated by minimally trained crews drawn from civilian populations, maintenance designed around basic mechanical aptitude rather than specialized technical training, performance that was adequate rather than optimal, practical rather than impressive, effective rather than elegant. The DUTW embodied this fundamentally different philosophy with almost insulting clarity. Its specifications were modest, by any objective technical standard. Its capabilities were operationally revolutionary, precisely because those modest specifications enabled mass production at scales German industry couldn't match. Not because German engineers lacked knowledge or skill, but because German industrial capacity was being stretched across too many competing priorities, while American industrial capacity seemed virtually unlimited. Weber's June 15th report documented a pattern that would influence his understanding of modern warfare for the rest of his military career and beyond. German defensive planning had assumed Allied logistics would collapse under the overwhelming complexity of supplying large forces across open beaches without port facilities. German assumptions were based on solid historical precedent and professional military analysis. But the DUKWs demonstrated that simplicity properly applied could defeat complexity, that adequate solutions deployed in sufficient numbers would overcome superior solutions available in limited quantities, that American industrial pragmatism could overwhelm German technical sophistication when backed by manufacturing capacity that German intelligence had catastrophically underestimated. The numbers Weber compiled with characteristic precision painted a picture of American industrial capacity that contradicted everything German intelligence had estimated about Allied productive capabilities. Over 21,000 DUKWs had been manufactured since design work began in early 1942. Production was accelerating rather than declining, as one might expect with experimental equipment. The Americans weren't carefully rationing these vehicles for critical missions. They were using them routinely, almost casually, as if amphibious trucks were normal military equipment rather than revolutionary innovations that challenged fundamental assumptions about warfare. This abundance revealed the fundamental asymmetry between German and Fähigkeiten. American approaches to industrialized warfare. Germany possessed superior individual technologies in numerous categories that German officers took professional pride in. Tiger tanks significantly outclassed American Shermans in armor protection and gun power. German aircraft engines demonstrated impressive engineering sophistication in materials and performance. Wehrmacht tactics reflected decades of professional military development and institutional knowledge. German soldiers were extensively trained and highly motivated, but America possessed something Germany couldn't match through engineering excellence or tactical brilliance. Industrial capacity sufficient to make adequate solutions overwhelmingly effective through sheer manufactured quantity. The DUKW wasn't technically a better amphibious vehicle than Germany could theoretically design if German engineers focused on the problem. It was demonstrably a more practical vehicle than Germany could afford to produce at militarily significant scales given competing demands on limited industrial resources. Its modest specifications reflected deliberate design choices that prioritized manufacturability over individual performance, quantity over quality, adequate effectiveness over technical excellence. American engineers, working with yacht designer Rod Stevens Jr. from the firm Sparkman and Stevens, had created a machine that could be built quickly, using standard automotive components, shipped efficiently using existing transportation networks, operated by anyone who could drive a standard truck, and maintained using basic tools that any mechanic possessed. German military culture, shaped by centuries of professional military tradition and Prussian emphasis on excellence, valued quality over quantity in equipment design. Precision engineering over mass production, individual capability over system efficiency, technical sophistication over operational simplicity. These values had produced remarkable weapons, systems that performed brilliantly in ideal conditions, and highly trained soldiers who could execute complex operations with impressive skill. But German industrial capacity couldn't compete with an opponent who could deploy thousands of adequate vehicles faster than Germany could deploy hundreds of superior ones, who could replace losses more quickly than those losses could be inflicted, who could sustain massive material expenditures that German planners could barely comprehend. Weber's analysis reached Wehrmacht headquarters in late June as part of broader assessments about Allied capabilities in the expanding Normandy campaign. His technical analysis of DUKW specifications was acknowledged as thorough and professional. His operational observations about their employment were filed appropriately. His strategic implications about American industrial capacity, overwhelming German technical advantages were noted, but essentially ignored by commanders focused on immediate tactical challenges. Germany was losing the war because of strategic decisions made years earlier regarding industrial mobilization and resource allocation. No amount of tactical brilliance at the division or corps level, no innovations in weapons technology, could compensate for fundamental industrial disadvantages that were becoming clearer with each passing week. By July, Weber was documenting expanded DUKW operations during the Allied breakout from the Normandy lodgment. The vehicles were supporting rapid advances inland across terrain that German planners had assumed would slow Allied movement. They were crossing French rivers without requiring combat engineers to construct bridges. They were navigating flooded areas that German forces had deliberately created as obstacles. They were maintaining supply lines under conditions that should have stopped conventional logistics cold. French rivers that German defensive planning had relied upon as natural obstacles slowing Allied advances were being crossed by DUKWs without requiring specialized bridging equipment or extensive engineering preparation. The Seine, the Loire, the Somme, major waterways that had shaped European warfare for centuries, had become highways for American vehicles that treated water as just another terrain type requiring modest adaptation. German defensive doctrine had consistently incorporated rivers as primary defensive positions that would channel enemy movement and create opportunities for counterattack. The Americans were treating those same rivers as minor inconveniences that their amphibious trucks could overcome in minutes, rather than the days required for conventional forces. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Weber watched the American advance with professional detachment that barely masked his growing awareness that Germany's ultimate defeat was mathematically inevitable, not because German soldiers lacked courage, training, or tactical skill. Not because German equipment lacked quality, or German officers lacked professional competence, but because American industrial capacity had created a fundamentally new form of warfare that German military doctrine, developed over centuries of European conflict, couldn't effectively counter with available resources. When your opponent could manufacture vehicles faster than you could destroy them through combat action, when their logistics were sustained by machines that didn't require the ports or railways that conventional military wisdom said were absolutely necessary, when adequate solutions deployed in massive quantities could overwhelm superior solutions available only in limited numbers, the ultimate outcome was determined by industrial mathematics rather than battlefield valor or tactical genius. The DUKW's revolutionary origin story, which Weber would learn about years later, exemplified everything that had gone wrong with German strategic planning. In March 1942, American military planners had identified the amphibious logistics problem that Weber now watched them solving. Major General Jacob Devers had approached the Office of Scientific Research and Development, an organization that brought together civilian scientists and military requirements rather than relying solely on traditional military bureaucracy. Within weeks, yacht designer Rod Stevens Jr. from Sparkman and Stevens had designed a hull. General Motors engineers had adapted a standard GMC 2.5-ton truck chassis. MIT researcher Frank Spear had developed the revolutionary tire inflation system. In just 42 days, from initial concept to working prototype, the Americans had created a vehicle that would help win the war. The prototype had initially been rejected by senior army officers who couldn't envision how it would fit into existing tactical doctrine. But then fate intervened in a way that perfectly demonstrated the DUKW's capabilities. During a December 1942 demonstration off Provincetown, Massachusetts, a massive storm with 60-mile-per-hour winds drove a Coast Guard vessel onto a sandbar. Conventional rescue craft couldn't reach the stranded crew through the violent surf and heavy seas. Rod Stevens himself climbed into an experimental DUKW, drove it into conditions that should have been suicidal for an unarmored vehicle with thin hull plating, navigated through waves that terrified experienced sailors, rescued all 7 Coast Guard crew members, and drove back to shore while military observers watched in stunned silence. Military opposition to the DUKW evaporated immediately. Production authorization was granted within days. By July 1943, 1,000 DUKWs were participating in the Sicily invasion, their first large-scale combat employment. This development timeline revealed everything about American and German approaches to innovation. Germany would have spent 18 months conducting studies. Technical committees would have debated optimal specifications. Multiple prototypes would have been built to exacting standards. The result would have been technically superior, but available in limited quantities months too late to affect operations. America had gone from concept to combat deployment in 13 months, accepting adequate performance in exchange for immediate availability and mass production capability. The approach violated every principle of German engineering culture, but proved devastatingly effective in actual warfare. Weber requested permission to examine captured DUKWs in detail, hoping to understand what German intelligence had so catastrophically missed. Division headquarters granted approval, and by July 2nd, Weber stood beside a DUKW that had been disabled by artillery fire near Carentan during American breakthrough operations. The vehicle had been recovered by Wehrmacht maintenance units and transported to a technical evaluation depot where German mechanics were conducting systematic analysis. Senior mechanic Klaus Hoffmann, a master craftsman who had maintained everything from motorcycles to Tiger tanks during his 20 years of military service, had spent 3 days examining every component of the disabled vehicle. His assessment was delivered with the brutally honest precision of a skilled craftsman evaluating a competitor's work without the filter of propaganda or nationalistic pride. The DUKW represents adequate engineering executed at massive industrial scale. Every component is designed for ease of manufacturing rather than optimal individual performance. Tolerances are loose by German standards where we typically measure in hundredths of millimeters. Materials are selected for availability and cost rather than theoretical superiority. The entire vehicle prioritizes quantity production over individual excellence. It's designed to be built by semi-skilled workers in automobile factories rather than by master mechanics in specialized facilities. Weber asked the question that had been troubling him since watching these vehicles drive out of the ocean on D-Day. If the design was so unremarkable by German technical standards, why had German engineers never developed something comparable? Why hadn't German military planners recognized this capability gap? Hoffmann's response was immediate and devastating in its clarity. "We could absolutely build a better amphibious truck in 6 months if we dedicated our best engineers to the project. We couldn't build 20,000 of them in 3 years using our current industrial capacity and resource allocation. The Americans didn't design the best possible vehicle that engineering knowledge could produce. They designed a vehicle that their automotive industry could manufacture faster than we could possibly sink them through combat action, and they did it using parts that were already in mass production for other purposes." The distinction was profound and professionally humiliating for German officers trained to believe in the superiority of German engineering. German technical excellence meant nothing strategically if American industrial capacity could overwhelm it through sheer numerical advantage. The DUKW succeeded, not despite its modest specifications, but precisely because of design choices that made Hoffmann wince as a craftsman. Every decision that German engineering culture would reject as insufficiently sophisticated made the vehicle easier to produce, simpler to operate, cheaper to replace, and more reliable in extended field service. Weber examined the tire pressure system that Hoffmann had identified as surprisingly sophisticated, despite the vehicle's otherwise utilitarian design. A driver-controlled mechanism allowed inflation adjustment from inside the cab through a compressed air system, providing optimal traction on any surface from soft sand to hard pavement, without requiring crews to dismount under potential enemy fire. This single feature, which seemed minor compared to armor protection or weapons systems, was revolutionizing beach operations by allowing DUKWs to traverse terrain that stopped conventional vehicles dead in their tracks. The bilge pump system showed similar practical brilliance focused on operational utility rather than technical elegance. High-capacity pumps could keep the DUKW afloat and operational even with holes up to 2 inches in diameter, penetrating the hull from rifle fire or shrapnel. The thin steel plating that German analysis had identified as a critical vulnerability was actually a calculated trade-off that American engineers had made consciously. Light armor reduced vehicle weight, increased cargo capacity, improved fuel efficiency, and made the vehicles cheap enough to produce in massive quantities. If some were inevitably lost to enemy fire, American industrial capacity could replace them faster than German guns could possibly destroy them. The mathematics were brutal but undeniable. Hoffmann showed Weber the maintenance manual that had been recovered from the disabled vehicle, a document that revealed American thinking about military equipment as clearly as any strategic planning document. It was written in simple English with clear illustrations that any literate person could follow. Basic maintenance required no specialized tools beyond what any commercial truck driver might carry in a standard toolkit. Major overhauls could be performed by minimally trained mechanics using standard automotive equipment available at any repair facility. Component replacement followed standardized procedures that required no advanced technical training beyond basic mechanical aptitude. The design philosophy was unmistakable and represented everything German military culture found distasteful. Create a vehicle that could be kept running by anyone with basic mechanical knowledge rather than requiring master craftsmen with years of specialized training. German military vehicles, by contrast, required skilled mechanics with extensive training, specialized tools often manufactured for specific purposes, and often factory-level expertise for major repairs. This reflected German commitment to engineering excellence and technical sophistication that German culture had valued for generations. It also meant German vehicles became useless scrap metal when supply lines were cut or when maintenance facilities were destroyed by Allied bombing. The DUKW, with its crude simplicity that Hoffmann found almost offensive professionally, could be repaired in a field workshop using improvised tools and scavenged automotive parts from civilian vehicles. American soldiers with basic mechanical training could keep DUKWs running under conditions that would permanently disable German equipment designed to much higher technical standards. Weber spent the afternoon watching Hoffmann's technical team meticulously document every aspect of the captured vehicle for the comprehensive report that German efficiency demanded. The mechanical simplicity was almost insulting to German engineering pride and professional identity, but the vehicle's devastating operational effectiveness was undeniable even to the most patriotic German engineer. The DUKW represented a fundamentally different approach to military equipment design that challenged centuries of German military tradition. American engineers had asked not, "What's the best vehicle we can theoretically build with available technology?" but rather, "What's the most effective vehicle we can build in the quantities needed to win this specific war with our specific industrial capabilities?" The answer was a machine that German craftsmen could criticize endlessly on technical grounds, while American logistics simultaneously overwhelmed German defenses through operational abundance that made technical criticism strategically irrelevant. Weber's July reports began incorporating strategic insights that would have been dismissed as defeatist or even treasonous earlier in the war when German victory still seemed possible. But by midsummer 1944, German officers were confronting operational realities that propaganda couldn't obscure and that professional honesty compelled them to acknowledge in classified assessments. The Atlantic Wall had failed not because German engineering was inferior or because German soldiers lacked courage. It had failed because German industrial capacity couldn't match American production across the full spectrum of military equipment. The Luftwaffe had lost air superiority not because German pilots lacked skill or because German aircraft were technically inferior. It had lost because American factories were building aircraft faster than the Luftwaffe could train replacement pilots to fly them, and faster than German industry could replace aircraft losses. German armor was superior on a tank-for-tank basis in many technical specifications. But American factories produced 5 Sherman tanks for every Panther Germany could manufacture, and they could replace battlefield losses in weeks rather than months. The numerical advantage overwhelmed technical superiority through mathematical inevitability. The DUKW exemplified this asymmetry with painful clarity. It wasn't a better vehicle than Germany could design if German engineers had focused on the amphibious logistics problem. It was demonstrably a more practical vehicle than Germany could afford to produce at scales that would influence the war's outcome. American engineers had solved the ship-to-shore logistics problem not through technical brilliance that German engineers lacked, but through systematic application of overwhelming industrial capacity to a clearly defined operational requirement. Weber's comprehensive analysis reached Wehrmacht headquarters in late July as part of broader assessments about Allied capabilities and German strategic options. His technical analysis was acknowledged as thorough and professionally executed. His operational observations were filed in appropriate intelligence databases. His strategic implications about American industrial capacity overwhelming German tactical advantages were noted in reports, but essentially ignored by commanders who lacked authority to address problems created by decisions made years earlier at the highest levels of government. Germany was losing the war because of strategic choices about industrial mobilization and resource allocation that had been made long before the first Allied soldier landed on Normandy beaches. No amount of tactical brilliance or technical innovation at the operational level could compensate for fundamental industrial disadvantages that were becoming clearer with each passing month of sustained combat. By August, Weber was documenting DUKW operations during the Allied breakout from Normandy's confining bocage country. The vehicles were supporting rapid armoured advances inland, crossing rivers and streams that German planners had assumed would require extensive bridging operations, navigating through deliberately flooded areas, and maintaining supply lines under battlefield conditions that should have collapsed conventional logistics. The Seine River, which German defensive planning had relied upon as a major obstacle that would force the Allies into predictable crossing points suitable for counterattack, was being traversed by DUKWs at multiple locations simultaneously. The Loire, the Somme, other significant waterways that had shaped European warfare since Roman times, had become minor tactical inconveniences rather than strategic obstacles. German defensive doctrine, refined through centuries of European warfare, had consistently incorporated major rivers as primary defensive positions. The Americans were treating those same rivers as temporary delays that their amphibious trucks could overcome in hours, rather than the days or weeks that conventional forces required for assault crossing operations. Weber watched the American advance through France with the professional detachment of a career officer who understood that personal survival required emotional distance from strategic catastrophe. But beneath that professional facade lurked growing awareness that Germany's ultimate defeat was inevitable, regardless of individual battlefield outcomes. Not because German soldiers lacked courage or training, not because German equipment lacked quality or sophistication, not because German officers lacked tactical competence or operational expertise. Germany was losing because American industrial capacity had created a form of warfare that German military doctrine, developed through centuries of European conflict and refined through 2 world wars, couldn't effectively counter with available resources and industrial capacity. When your opponent could manufacture replacement vehicles faster than combat could destroy them, when their logistics operated using equipment that didn't require the ports and railways that all previous military theory insisted were absolutely necessary, when adequate engineering solutions deployed in overwhelming quantities could operationally overwhelm superior individual equipment available only in limited numbers, the war's outcome was determined by industrial mathematics rather than battlefield heroics. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.